Welcome to Easy BTech, your guide for BTech and beyond. In this channel, you can learn the subject very easily. So, my name is G. Sampath. I am going to explain the subject VLSI design. Today, we are going to discuss about the topic layout diagrams. Layout diagrams. Layout diagrams. So, what is layout diagram? Layout diagram is nothing but designing of a MOS transistors by using dimensions and layers. Designing of transistors, design of transistors, design of transistors by layers, different layers with dimensions, layers with dimensions, layers with dimensions. So layout is representation, basically two types. First one is single polysilicon double metal, single polysilicon double metal. Only single polysilicon using two metals, double metal, metal 1 and metal 2, two metal, double metal, right? Second one is double polysilicon. Two polysilicons are used. Double polysilicon, double polysilicon, double polysilicon, double metal, double metal. So two polysilicons are used, poly 1, poly 2, double metal. So we can use single polysilicon double metal is for Nmos design. Nmos design. We can use this double polysilicon for Cmos, and also we can discuss it. We can also use it in BiCMOS also. Okay. So let us see these two today. First one, single polysilicon double metal. Single polysilicon double metal. Single polysilicon. So what is polysilicon? It acts as a gate. It is the multiple elements of silicon. So polysilicon, single polysilicon double metal, okay. So let us see this one. So we have different layers. Important layers are N diffusion. Layers you should remember carefully, okay. So N diffusion to N diffusion, what is the distance between this? Now we have P plus diffusion is yellow, P plus diffusion, and the distance between P plus diffusion to P plus diffusion, and we have polysilicon is a red color, this is a polysilicon to polysilicon, right? So the layer is here, we can say backward lines, nearer distance. It is a representation of a polysilicon, backward lines, nearer distance. You see, it is a polysilicon act as a gate terminal, right? So what is the dimension of this one? It is 2 lambda. This is also 2 lambda. So the feature size representation. So lambda is a size, feature size means length and width. feature size. Lambda is feature size 2 lambda. So length and width. So 2 lambda into 2 lambda. If you are mentioning here means this length is equal to 2 lambda, width is equal to 2 lambda, right? And diffusion also. Diffusion also 2 lambda. 2 lambda means length 2 lambda, width 2 lambda. This is also 2 lambda. This length 2 lambda, width 2 lambda, right? And we have this representation forward lines with distance. This is a layer representation, and also forward lines the distance. And we have end diffusion, forward lines nearer distance, forward lines nearer distance, end diffusion. The representation n plus diffusion, n plus diffusion, n type impurities dopants, mostly used phosphorus, right? So this is n plus diffusion, n plus diffusion, n plus diffusion, n plus diffusion for source and drain Nmos transistor. Now this is P plus diffusion, P plus diffusion for source and drain Pmos transistor we used. Now this one polysilicon. So polysilicon, this is polysilicon, right? Polysilicon, okay. You can write this one. Polysilicon act as a gate terminal. Color is red color. Polysilicon. Polysilicon. So the color is it is a red color. You see, this is a red color, and this is a yellow color, yellow color, and this one is a green color. Green. In diffusion is green color, where we discussed in stick diagrams. So in diffusion is green color, P diffusion is yellow color, and polysilicon is for backward slashes with a red color representation. Okay. Now, now here, from here to here, from here to here. So P plus diffusion to P plus diffusion, N diffusion to N diffusion. How much it is? Distance is 3 lambda, and here also, and here also. N diffusion to polysilicon, P diffusion to polysilicon. The distance is 1 lambda, and polysilicon to polysilicon, the distance minimum separation is 2 lambda, right? So we have a double metal. Two metals are here. Two metals. Metal 1 and metal 2. So metal 1 is used. Metal 1 to metal 1 separation. Right. Metal 2 is here. Metal 2. Okay. Metal 2. So the representation of this one, metal 1 is vertical lines. Right. Vertical lines. This is a vertical line representation, metal 1. Now horizontal lines, metal 2, metal 2, double metal, two metals are used in the designing. So metal 2, this is metal 2, metal 2. So metal 1 is 3 lambda, length and width 3 lambda. So 3 lambda, if you are mentioned, means length 3 lambda, width 3 lambda. This is length and this is width. So length 3 lambda, width also 3 lambda. Minimum separation, metal 1 to metal 1 3 lambda. Metal 1 to metal 1 3 lambda. So metal 2 is 4 lambda and 4 lambda. So width and length should be same, 4 lambda into 4 lambda. So here also separation is 4 lambda, right? So what is metal 2 and what is metal 1? So metal 2 is used. Metal 2. Metal 2 is used for supply VDD and VSS. VDD, VSS. So power supply. power supply. It is used power supply, right? So VDD VSS, where the connections, when you are designing of NMOS transistor, when VDD VSS are there you can use metal to horizontal lines, dimensions 4 lambda, 4 lambda, metal 2 to metal 2 separation is 4 lambda. So the color is blue color. The color is, we can say it is a dark blue. You can say it is dark blue. It is dark blue, and metal 2 is dark blue, metal 1 is blue. Metal 1. Metal 1 is we used input output interconnection. V in, V out, V in, V out, and interconnection. Input output interconnections. Interconnection transistors. Interconnection transistors. Interconnection between transistors. Right? Transistors. And this is used for metal 1, metal 2, and metal 1. Now we have black contact. For contact area, two layers are joining, so we can use black contact. Black color is black contact. So black square box representation, where we discussed in black color, used in stick diagrams, right? Now if Nmos representation, let us see Nmos enhancement. Nmos enhancement. Let us see symbol. Nmos enhancement symbol, if you see, so this is Nmos enhancement. Nmos enhancement. So this one is a gate, drain, and source. So layer representation. This is a layer representation. You see layers and layout layers. Otherwise we can say it is a layout. Can say it is layout. So layout is dimensions with layers. So drain and source and diffusion, forward lines, the nearer distance. And gate, you see this one is a gate. Gate is deposited on drain and source. Now gate is deposited on this. Like these two are separated, drain and source. Polysilicon is separated by thin oxide. Now backward slashes with nearer distance. You see this one. So length into width. L into W ratio. So it is 2 lambda into 2 lambda. Into 2 lambda. So this is a width. And length. So length and width are same. So polysilicon. So this width and length should be 2 lambda, and this is also length and width also 2 lambda. So 2 lambda into 2 lambda. This is 2 lambda and this is 2 lambda. So both are polysilicon is also 2 lambda, and this one is also diffusion also 2 lambda into 2 lambda, right? Let us see this one. Nmos depletion. If you see Nmos depletion, you see Nmos depletion. Nmos depletion. Nmos depletion. So how can you represent this in a circuit diagram and circuit diagram symbol and layout? Now this is a Nmos depletion means thick line between drain and source, right? So gate, drain, and source. And layout diagram for this. layout diagram for this. So red over yellow, red layer and yellow layer. So below yellow layer, this is below yellow layer, red over yellow. This is red over yellow, red over yellow. Both are separated by thin oxide. Right, backward lines near distance, backward lines near distance, and yellow is you can say backward lines, forward lines with distance, separation. You see, back forward lines with distance, forward lines. Green color is there, it is a diffusion. Yellow color is there, this is a P diffusion. So this is P plus diffusion, P plus diffusion for source and drain of Pmos transistor. Right? Let us see the dimension here. This is also 2 lambda into 2 lambda, length and width 2 lambda. So this width 2 lambda, length 2 lambda, length 2 lambda, width also 2 lambda. Right? This is a width of polysilicon, width of polysilicon. Sorry, this one is width of polysilicon, length of the channel, width of polysilicon, length of the channel. So this is length of the channel. Right? 2 lambda into 2 lambda. Now we can say, you can see this one Pmos enhancement. When we are designing Cmos, so there Pmos is required. Pmos enhancement, right? Pmos enhancement. We can see this one. So the diagram Pmos. This is Pmos, right? Pmos. So bubble across the gate terminal, gate, drain, and source. So how can you represent this one? Right? It is a depletion mode transistor. You see this one, ma. So it is a red over yellow, red over yellow. Pmos is red over yellow and red over yellow with red over yellow, right? Red over yellow, right? So the forward line, backward lines with nearer distance, and yellow color forward lines distance. So dimension of this one is 2 lambda, 2 lambda into 2 lambda. So depletion, Nmos depletion means it is a green color. So it is Nmos. Nmos means green. It's not yellow. It is a, this is a green. Right? This is a green color. It's a green color. This is N plus diffusion. Right? N plus diffusion. This is N plus diffusion. Where this one is a P plus diffusion. This is a P plus diffusion. P plus diffusion. And here one more thing. L dotted line is there. Depletion means dotted line. Right? Implantation. In the stick diagram, we represent a depletion dotted line. So this area is 6 lambda into 6 lambda. This area is 6 lambda into 6 lambda. 6 lambda into 6 lambda. Right? 6 lambda into 6 lambda. Nmos, red over green. 2 lambda into 2 lambda. Depletion, red over green, not yellow. Red over green. So with implantation, 6 lambda into 6 lambda. Pmos enhancement, red over yellow. Right? The layer is forward lines distance. So backward lines near distance, poly 1, red over yellow. So it is also 2 lambda into 2 lambda. Right? Let us see Pmos inverter or Nmos inverter. Let us see Nmos inverter and his layout and the layout diagram. Nmos inverter, Nmos inverter layout diagram. Layout diagram means dimensions and layers. Diagram, layout diagram. Nmos inverter layout diagram. Let us see this one. So what is the Nmos inverter? Nmos inverter we read a VSS, pull up transistor and pull down transistor. Pull up transistor and pull down transistor. Right? This is a depletion mode transistor. So depletion mode transistor. and we have enhancement mode transistor. Enhancement mode transistor, right? Like stick diagram we can draw, but you should mention difference between layout diagram and stick diagram. We can represent with dimensions, layers with dimensions. VDD VSS. Now this is a V out. So it is a depletion mode transistor, depletion transistor. This is a depletion mode transistor, enhancement mode transistor, enhancement mode transistor, right? We are applying a V nor here. So how can you draw the layout diagram for this? Layout diagram, VDD VSS are blue layer, right? VDD VSS are blue layer. We are using metal 2, blue layer metal 2, right? Metal 2. So metal 2, how can you represent horizontal lines? This is metal 2. You can say metal 2. Now below one is VSS, VDD VSS, VDD VSS, right? This is horizontal line. This is horizontal line metal 2, horizontal line metal 2. Now we have diffusion. Diffusion we can say take both single color because drain and source, drain and source. So we can say this one, and color is gate color is red color, red over green, red over green, right? Red over green, right? Red over green here, red over green, and we have polysilicon. Red over green, it is a red over green, it is depletion mode transistor, and yellow and implantation is there, right? So it is a forward lines. This is a backward line representation. Diffusion is a forward line representation, right? We can say forward line representation, okay? And yellow implantation. The color we can say it is a yellow implantation. Implantation is yellow color. Yes, also you can say it is a yellow implantation. You can take this yellow implantation in depletion, right? So yellow implantation. Another we can represent this contact area. So this is a contact area. Both layers are here. Both layers are here. You can represent this contact area. Here also contact area. Contact area, right? Now let us take this diffusion is also here. Forward lines with the nearer distance, and diffusion, and we have metal. Metal is output terminal. Okay, metal is vertical line, and polysilicon metal interconnection point over there, right? Interconnection point here also, interconnection point is there. Interconnection point is there. You see this one more. Now let us see. So this is VDD, dark blue. We can say dark blue. Dark blue color, VDD. Okay, VSS also dark blue color. You can say it is a dark blue color. And Vout is blue. Vout is color is a blue color. Vout is blue color. So it is metal 1, metal 2, right? What is the dimension of this one? It is 4 lambda into 4 lambda. Metal 2 is 4 lambda into 4 lambda. So VSS also 4 lambda into 4 lambda. Right here, this one is 3 lambda into 3 lambda. Metal 1 is 3 lambda into 3 lambda. 3 lambda into 3 lambda. Now polysilicon also 2 lambda into 2 lambda. 2 lambda into 2 lambda. Here also 2 lambda into 2 lambda. Polysilicon. Okay. And diffusion is 2 lambda into 2 lambda. 2 lambda into 2 lambda. And where contact area is 2 lambda into 2 lambda. 2 lambda into 2 lambda. This length and width, it's a square box. square box, right? So polysilicon to polysilicon separation, we can say minimum from here depletion to enhancement should maintain minimum is 1 lambda separation, as we are seeing, the first one. So polysilicon to polysilicon, it is a 2 lambda separation. So you see this one, it is a 2 lambda separation. It is a 2 lambda separation. So it is a 2 lambda separation. Minimum is 2 lambda separation, right? And metal 2 to metal 2. Metal 2 to metal 2 separation is metal 2 to metal 2 separation is how much it is? 4 lambda separation. Metal 2 to metal 2, it is minimum is 4 lambda separation, right? 4 lambda into 4 lambda. So minimum 4 lambda separation. It is 4 lambda into 4 lambda. Separation is 4 lambda. So whenever we are representing a layout diagram, is nothing but representation of this transistor symbol with layer and dimension. How much length and width? How much length and width? So each layer is having length and width, right? Let us see one example so that you can understand more. Let us, for example, y is equal to a into b plus c. Y is equal to a into b plus c. So draw the layout diagram. Layout diagram. Layout diagram. Layout diagram. Layout diagram in Nmos. In Nmos design. In Nmos design. In Nmos design. First we draw the circuit diagram, then draw the layout diagram. So this is a circuit diagram. Circuit diagram. Above is always depletion mode transistor. Above is always depletion mode transistor, right? The below is this A is in series. A is in series with the B plus C. A is in series with the B plus C. So A is into like AND gate, okay, and B plus C it is OR gate, right? Here we can take depletion mode transistor, and from here to we can take as output, right? Right there it is interconnection point, interconnecting point. Now now this is a VDD, VDD, VSS, VSS, and this is a V out, this is a V out. Now A, B, and C, right? A, B, and C inputs are here, right? Let us see this one in layers representation. So what is VDD, VSS? We use single polysilicon double metal, only single polysilicon, metal 2. This is metal 2, metal 2, metal 2, metal 2 is here. This is also metal 2, right? You will see the green color representation. You can take directly a single diffusion over here. Now we have one diffusion over here and interconnecting from here to here. Interconnecting from here to here, drain with a green color, green color. So we can take this portion directly, green color, from here to here direct, as like a stick diagram, but layers are here, okay. So what is a layer here? Backward line, forward lines with nearer distance, forward lines with nearer distance, right? Forward lines with nearer distance. Here also end diffusion, forward lines with nearer distance, right? We have take polysilicon depletion. This is a depletion layer, depletion polysilicon. You can mention this one. You can mention this one, the short circuited polysilicon, okay. and here also one polysilicon is there. Here also A is a series polysilicon, and here is a parallel B and C, polysilicon B and C, B and C. So it is backward lines with nearer distance, backward lines with nearer distance, right? Backward line nearer distance. That is a polysilicon, backward lines, backward slashes nearer distance. Now we have metal. Metal is horizontal line. Metal 2. VDD VSSR metal 2. VDD VSSR metal 2. VDD VSSR metal 2. And here we can take output metal 1. Output metal 1. So it is vertical line. Right? Vertical line. Let us represent the dimensions. So metal 2 is 4 lambda into 4 lambda. It is 4 lambda into 4 lambda. Right? This is also 4 lambda into 4 lambda. 4 lambda into 4 lambda. Minimum separation from here to here, it is metal 2 to metal 2. Minimum separation is 4 lambda. Minimum separation is 4 lambda. Now, metal 1, how much dimension? 3 lambda into 3 lambda. Right? Now, let us represent this polysilicon. Polysilicon is 2 lambda into 2 lambda. This is also 2 lambda into 2 lambda. Length and width 2 lambda. 2 lambda into 2 lambda. Right? Here also 2 lambda into 2 lambda. Right? So minimum separation from here to here is 2 lambda separation. Okay. And end diffusion. End diffusion, it is 2 lambda into 2 lambda. So length and width should be 2 lambda. The minimum separation end diffusion to end diffusion is from this one. It is 3 lambda separation. Right. Now we have contact area. Two layers are joining here. End diffusion and metal 2. Here also end diffusion and metal 2. Here also end diffusion and metal 2. Here also end diffusion and metal 2 contact area. So overimposed 4 lambda, but the actual area is 2 lambda only. 2 lambda into 2 lambda. It is a square box representation, right? Another type, another type we can say, second one, double polysilicon, double metal. Double polysilicon, double metal. Polysilicon, double metal. Double metal. So two metals are here. Two metals, two polysilicons. Two metals, two polysilicons. Let us see this one. The layers are end diffusion separation. You should remember this. And we have yellow is P plus diffusion, P plus diffusion, P plus diffusion, and we have poly 1 and poly 2. Poly 1 is red color, poly 2 is orange color. So poly 1 is red color, poly 1 separation, but color is not there. So this one is poly 2 separation, poly 2 separation. So it is backward lines nearer distance, backward lines nearer distance, right? Backward lines nearer distance, poly 1. So backward slashes with distance, backward slashes with distance, it is poly 2, right? And this one is forward lines with nearer distance, end diffusion. This is end diffusion. So it is forward lines with nearer distance, end diffusion. And yellow, forward lines with separation, forward lines with separation, right? Let us see the layers representation. Let us see the layers representation. So this is 3 lambda into 3 lambda, length width 3 lambda, length width 3 lambda, and P diffusion also length width 3 lambda, and polysilicon it is 2 lambda, this poly 1 2 lambda, right? So minimum separation P diffusion to P diffusion is this is 2.5 lambda, this is 2.5 lambda, and this one is 1 lambda, right? 1.5 lambda, 1.5 lambda. This is Poly 1 to poly 1, 2.5 lambda, and this is 3 lambda. This is 3 lambda. Now metal 1, metal 1, we can say metal 1, metal 1 distance, double metal, two metals, metal 1, metal 2, same. But dimensions is different. Dimensions is different. Two polysilicons and N diffusion, P diffusion, separation. So dimensions are different. So this is used in CMOS, CMOS inverter, CMOS inverter, right? Let us see this one. So metal 1 is vertical line, metal 2 is horizontal line, metal 2 is horizontal line, right? Let us see the representation. It is 2.5 lambda, metal 1, 2.5 lambda length and width, 2.5 lambda. Separation is also 2.5 lambda. Previously it is 3 lambda. Now it is 2.5 lambda. Metal 1. Metal 1. Now metal 2. Metal 2. Metal 2 is 3 lambda. 3 lambda. Length width 3 lambda. Separation is also 3 lambda. Okay. And this one is also 3 lambda. Length 3 lambda. Width 3 lambda. So it is 3 lambda representation means length and width. L into W. L is to W. Do one example. Let us see. CMOS inverter. CMOS inverter. CMOS inverter layout diagram. So two polysilicons are there here. Layout diagram. So joining of poly 1, it is used for poly 2. So poly 2 is, this is poly 2, right? Polysilicon 2. This is poly 2 is orange color. This is orange color representation. Okay. Anyhow, this one is a red color. This is a red color. Now N plus diffusion is green. N plus diffusion is green. Green. And P plus diffusion is yellow color. P plus diffusion is yellow. Okay. So CMOS inverter means CMOS inverter means Pmos and Nmos. Right. Let us draw the diagram. circuit diagram. Circuit diagram and layout diagram. Right. Pmos. The above pull-up transistor is Pmos, and below pull-down transistor is Nmos. Both are in enhancement, but common input is applied in CMOS. Common input is applied, right? So CMOS bubble is there, VDD and VSS. Okay, this is a V out and V in, right? So we can represent in layout. Here we use double metal, two metals, metal 2, metal 1, and also we use two polysilicons, poly 1 and poly 2. Poly 1 and poly 2, right? Poly 1 and poly 2 more. Let us see this one, right? So red over yellow. Pmos means red over yellow. You see, this is a yellow P plus diffusion, and we have green N diffusion. N diffusion. N diffusion is here, right? The common polysilicon. This is poly 1 is used gate terminal. 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 And here the interconnection, this one is poly 2. Interconnection, this one is poly 2. So this is polysilicon 2 more. This is poly 2, orange color. The gate terminal, the actual gate terminal is red color. The actual gate terminal is red color. The actual gate terminal is red color. Now anyhow, this one is a yellow color representation. P plus diffusion. This is a green color representation. This is a green color representation which we mentioned here, right? So orange is color is not that. Let I am representing the here from here to here, right? Interconnection, right? And we have metal one. Metal one here we can take input. We can take input and interconnection from here to here also we can use metal one, and output is there. Output metal one. Output is also metal one, right? Where metal one is a vertical lines. Metal one is a vertical lines here. Input and output signal distribution. Where VDD VSSR power distribution. VDD global power distribution in the circuit. Now this is horizontal lines. We can represent this is horizontal lines, horizontal lines. Okay. Now we have this one polysilicon backward lines nearer distance, backward lines near distance. So backward lines with the distance, it is a poly 2, right? So forward lines with the distance, it is yellow. So forward lines with the nearer distance, it is a N plus diffusion, green color. Now contact area is there. That contact area is black color, square box, black color, 2 lambda, 2 lambda. Right? Let us see the representation. Here is also contact area is there. Here is also the contact area is there. Right? Joining of metal 1 and poly 2. Right? Let us representation. So this is poly 2. This is poly 2 is orange color. Orange. The color is here orange color. This is an actual gate terminal. This is poly 1. So poly 1 is red color. Poly 1 is red color. The actual it is poly 1 red color. Poly 1 is red color. Right. So metal 1 is blue. How much it is? 2.5 lambda. 2.5 lambda into 2.5 lambda. If you are mentioned here 2.5 lambda means 2.5 lambda into 2.5 lambda. So this is 3 lambda. This is 3 lambda. So 3 lambda into 3 lambda. Separation is also 3 lambda. So minimum separation from here to here is 3 lambda. Right? 3 lambda separation. Minimum separation is 3 lambda. And poly 1. Poly 1 is 2 lambda. So this is 2 lambda. This is also 2 lambda. Poly 2 is also 2 lambda. Poly 2 also 2 lambda. Now N plus diffusion. So it is changes than single polysilicon double metal. So this one is N plus diffusion is 3 lambda into 3 lambda. Length and width 3 lambda into 3 lambda. So P plus diffusion also 3 lambda into 3 lambda. 3 lambda into 3 lambda. Right? So separation poly 1 to poly 1 to poly 1. So from here to here, the minimum separation poly 1 to poly 1 is minimum separation is it is 2 lambda. 2.5 lambda. You can see this one. 2.5 lambda. Poly 1 to poly 1, 2.5 lambda. Like, let us represent this one, another one. So, as the circuit is here, according to the circuit, we can draw with layers and dimensions, length and width. So, how much length is required? How much width is required? So, for this Nmos designing, how much diffusion length and width? How much polysilicon length and width? Right? Metal. So, signal interconnection metal layer from here to here. If you take from here to here, from here to here, so how much metal layer is length and width is here. Now, how much output terminal length and width is here, right? How much input signal length and width is there. So that's why we can represent layout means dimensions with layers, right? Last one we can see Cmos. Anything we can draw circuit diagram and layers with dimensions. Let us see Cmos Nand gate. Cmos Nand gate. So with the gate representation also, Cmos Nand gate. Cmos Nand gate layout diagram. So last we can See this one. So Cmos NAND gate means VDD VSS. VDD VSS. NAND means AB complement. AB complement means A and B are A and B are series. A and B are series, and PMOS transistors are parallel. PMOS transistors are parallel, right? PMOS transistors are parallel. PMOS are parallel. You can say input terminal A, and this is B. This is A, and this is B. So V out diagram, V out, it is AB complement. AB complement. So this is VDD and VSS. VDD VSS. So we can connect this one by means of poly. This is poly. What is a poly 2, right? You can say this one. You see, so A is the input terminal. A is in AA, so two inputs are here. Let us see this one in layout diagrams. Layout diagrams are metal 2, metal 2, metal 2, right? Metal 2. So metal 2 here, metal 2, right? Metal 2. So afterwards we have this is a bubble across the gate terminal. Bubble across the gate terminal. Now this is N diffusion. This is also N diffusion. N diffusion. Both are in parallel and two series. Which one series? Green color. So green color representation. Green color representation. Can take this color from here to here. Now let us take polysilicons. How many polysilicons are here? Two polysilicons. Poly 1 is the actual gate. Poly 1 is the actual gate. And poly 2 is the interconnection. Right? This is a poly 1 from here to here. Poly 1 from here to here, actual gate. And poly 2. Poly 2. So interconnecting from here to here by using poly 2. The layers you can identify. How can you identify this one? By layers you can identify. By layers you can identify, right? So backward lines with nearer distance. It is poly 1. Backward lines nearer distance. Poly 1 actual gate area. This is actual gate area. Actual gate area. Poly 2 is with the distance. Poly 2 is a distance. Like N plus diffusion, P plus diffusion. Orange color. Okay. Now we have metal 2 is horizontal line. Metal 2 is horizontal line. Metal 2 is horizontal line. Is a dark blue. Metal 2 is horizontal line, dark blue. And we have N diffusion, green color, right? P diffusion, forward lines with the distance. Forward lines with the distance. And here we can take input A. A is the input. Okay. So from here we can take input to A and B. A and B. Right? Vertical line here. Vertical line here. Right? Vertical line here. Okay. And interconnection that this P plus diffusion. P plus diffusion, and from here to here metal 1 interconnection. This one, this part, the output terminal, metal 1, and we can also take this output terminal, metal 1, right? So let us represent this dimensions. Metal 1 is 2.5 lambda. Metal 1 is 2.5 lambda. Input terminal. This is output terminal 2.5 lambda. Okay. Now metal 2 is 3 lambda. This is also 3 lambda into 3 lambda. Minimum separation is from here to here is minimum separation is 3 lambda. Not anything we can represent. This is a 3 lambda into 3 lambda. 3 lambda into 3 lambda. So P diffusion to P diffusion separation is 2.5 lambda. 2.5 lambda. Right? Poly 1 is 2 lambda into 2 lambda. Poly 2 also it is 2 lambda. And separation poly 1 to poly 1 minimum separation is 2 lambda, like this 2.5 lambda, right? This poly 1 is 2 lambda into 2 lambda, 2 lambda, it is 2 lambda, 2 lambda, length and width 2 lambda. Diffusion is 3 lambda into 3 lambda. And contact area 2 lambda into 2 lambda. This is a contact area, P plus diffusion and metal 2, P plus diffusion metal 2, P plus diffusion metal 2, and metal 1, right? And here also diffusion to metal, here also diffusion to metal. We can take from here to here, right? Here interconnection point is here, and interconnection point from here, right? Now where is interconnection point? This is also interconnection point, this is also interconnection point. So double metal double polysilicon is in Cmos, single polysilicon double metal is in Nmos design. So please subscribe the channel, like, and inform to your friends, right? Thank you.